Welcome to Unit 3 on trigonomic functions. This is part 2 of graphs of sine and cosine. So now that we've talked about how these functions are, well, really functions, and they have inputs and outputs, and those inputs and outputs are real numbers, and that we use that unit circle as a guide to help us determine what the inputs and outputs are. Now what we could do is we could really examine their graphs. We could actually start to make a graph of the sine function. And this is going to be a little bit tricky at first, but I think you'll catch on and get used to it. So let's talk about that sine function. Let's go back to that chart we made earlier. Now this one's much cleaner and nicer. I have it all typed up here. So again, if you ever watched part 1, then you're like, how did you make this graph? How did you make this input-output table? Go back and watch part 1. So here we have our inputs. Remember, the inputs are angles. So the first thing I have to understand is that the x-axis, the axis that represents inputs, now represents angles. So notice that on my x-axis here, I actually have labeled pi over 2, pi, 3 pi over 2, 2 pi. And then obviously there'd be increments. So right here, halfway in between 0 and pi over 2 would be pi over 4, and so forth. Hopefully that makes a lot of sense, I hope. Okay. So, and then the other thing too is, like, you know, if you take pi over 2, like that's that first quadrant, and you divide it by 3, that's your pi over 3, your pi over 6, your pi over 3, and your pi over 2. So what I guess I'm trying to get across is that each of these tick marks represents pi over 6. We got 1, 6, 2, 6, 3, 6. 3, 6 pi is 1/2 pi. 4, 6, 5, 6, 6, 6. That's my pi, and so forth. So you have to really understand that my x-axis, my inputs, have angles. Now, angles are numbers. Please, let's not confuse that. Like pi over 6, grab a calculator if you need to. Pi over 6, it's not like some crazy made-up thing. Pi over 6 is a number. It's about 0.52. Pi over 4, again, it's a number. It's a number. It's not like just some symbol that's just standing for nothing. It's pi over 4 is a number. It's 0.79-ish, right? It's, you know, actually it's irrational, but it's a decimal. And then even 2 pi is about 6.28, right? 2 pi, 2 times 3.14, about 6.28. So these are numbers, and you could put numbers on a number line, which is the x-axis. Now, the outputs are, of course, the y-coordinates from the unit circle. So where did I get all these outputs from? I looked at that unit circle. Now what I can start doing is actually graphing these points. So the first point is 0, 0. And again, make sure you understand, don't just understand blankly that it's 0, 0. Understand what that 0 on the x represents and what the 0 on the y represents. So at 0 radians, at an angle of 0 radians, the y-coordinate from the unit circle is 0. And again, look at your unit circle, you can see that. And then at pi over 6, which is this first tick mark here, we are at 1/2. So I'm actually going to have this second tick mark be 1. That means each tick mark is a half. So this is 0.5, 1, negative 0.5, negative 1. Okay, so at pi over 6, we are at 0.5. So there's that point right there. At pi over 4, we were at 0.707. So again, radical 2 over 2. So at pi over 4, which is halfway in between 0 and pi over 2, at pi over 4, we are 0.707. So again, obviously you kind of have to eyeball this, but maybe somewhere right around there. And then at pi over 3, the second tick mark, right? Pi over 3 is 2, 6. 2, 6, we reduced to pi over 3. So at 2, 6, or pi over 3, I'm at radical 3 over 2, which is 0.866. So really, really close to 1, right? It's definitely higher than the previous point, which was 0.707, but still less than 1. And then finally at pi over 2, sine of pi over 2 is exactly 1. So if you think about it, this is my first quadrant. So it starts out at a y-coordinate of 0, and then if you follow that unit circle and you start in a positive direction, the next point we come to is at pi over 6, so we're at 1/2. Then at pi over 4, we continue to increase to radical 2 over 2, which is 0.707. Then at pi over 6, or excuse me, pi over 3, we increase a little bit more to radical 3 over 2, which is 0.866. And then at pi over 2, we reach the maximum value, the maximum y value, 1. Now let's keep going. Now remember, we're going to skip a couple values because you don't need to graph every single point when you're making a graph. you know, I just have to graph some of them. So at pi over 2 or 1, then at pi we jump back to 0. So again, at pi we jump back to 0. Now you can track what happens in between pi over 2 and pi. All you gotta do is look at that unit circle, but the points kind of go in reverse, right? At 4 pi over 3, it goes back to radical 3 over 2. At 3 pi over 4, it goes back to radical 2 over 2, 0.707. At 5 pi over 3, it goes back to 1/2, or sorry, 1/2 right there. My fault. So I hope you get the idea. And then we can keep going. At 3 pi over 2, it drops down to -1. And then if we keep going to a full circle 2 pi, we're back to 0. So here is the sine curve, and it's like a nice wave. It's a nice smooth wave. The y value from the unit circle increases, and then it hits the top at 1, and then it starts to decrease. Sorry, I'm kind of missing the points there. And then it curves back down real nice, hits its min at -1, and then back to 2 pi. So, ladies and gentlemen, this is a full wave of sine. Starting at 0 radians, again, I'm thinking only about the y-coordinate. The output of sine is the y-coordinate. The y-coordinate goes up, it goes up, it goes up, it goes up until it reaches the biggest y-coordinate on the unit circle, which is +1. And then it starts to drop back down as we continue to rotate around that unit circle. We start to come back down, and at pi, we hit 0. The y-coordinate pi is 0. And then as we continue to rotate, our y values now dip down into the negatives. They dip down into the negatives. They dip down into the negatives. And at 3 pi over 2, they reach the absolute min at -1. And then they continue to come back up from that, in that fourth quadrant. They come back up, up. And at 2 pi, they come back to 0. So there is a sine curve. Now, remember, we can keep going, right? We don't stop at 2 pi. We can keep going. Or, in fact, we can actually go around a circle in a negative direction, which is really fun. So we could graph this sine curve in either direction. So again, look at this unit circle. I really want you to understand that as the angle input gets bigger, the y-coordinate makes this wave. Again, follow the y-coordinate. Just kind of follow it with my mouse, ready? As the radians increase, the y-coordinate goes up. Again, I'm thinking solely about the y-coordinate of where my mouse is. It's up. It's getting higher. It's getting higher. It's getting higher. It's getting higher. Then it reaches the absolute highest the y-coordinate will ever be, 1. And then I keep going. I keep going. I keep going. But now my y-coordinate is going down. So now the graph is going down. It's going down. It's going down. And then at pi, a half circle, it reaches 0. And then it keeps going, and it keeps going. And now it's dipping down to the negatives. Now the y-coordinates are negative, more negative, more negative, more negative, more negative, until it reaches the absolute min of -1. Again, y-coordinate. And then it starts to go back up. It starts to rise and rise and rise. It's still negative, but it's rising, it's rising, it's rising. And then it hits the full circle. And then guess what? It just keeps going, and it just keeps repeating and repeating and repeating and repeating itself, going around and around and around and around and around. And every cycle around is called a period. And we could even go opposite, right? We could go backwards. We could go in the negative direction. If I go in the negative direction, I actually start going backwards, right? And now I'm going down, down, down. And then I go to -1. And then I come back up. I come back up. I come back up to 0. So what would that look like on the graph? Well, first off, make sure we understand that my y's are going by half. So that's 1 and -1. So again, thinking about in that positive direction, starting at 0, 0. I go up, I go up, I go up. At pi over 2, I reach the max. I come back down, I come back down, I come back down. At pi, I reach 0 as the y-coordinate. And then at 3 pi over 2, I hit that -1, and then I come back up. And then again, I just keep repeating it. It's just going to keep doing this over and over again. And again, I can even go in that negative direction. If I go in that negative direction going down, or in that clockwise direction, the first thing is I go down, I reach that -1, and then I come back up and I reach that 0 at -pi. So if I'm going this way, that'd be -pi. And then I keep going up, and at -3 pi over 2, I hit that +1. And then at -2 pi, I come back to 0. And it's just going to keep doing this forever and ever. So the sine curve goes all left forever and ever and ever, and goes all right forever and ever and ever. So let's talk about some of its key features. So first off, the domain is -infinity to infinity. There, again, you can keep going around in a circle, right? Radians never stop. They keep getting bigger and bigger and bigger. Yes, you are repeating the y values as you go around that unit circle, but you can keep going around and around and around in either direction, even negatives. Now, the range is -1 to 1 because the outputs are stuck. Remember, the biggest y coordinate is 1, the smallest y coordinate is -1. So you're stuck between -1 and 1. It's always continuous. There are no points of discontinuities, no jumps, no vertical asymptotes, and certainly no holes. It does have an absolute max at 1. It actually repeats it. There are several of them. There's actually an infinite amount of them because this wave, this kind of beautiful wave, this up and down wave, continues on forever. There's an absolute min at -1. And again, there's several of them. And there's no asymptotes. You don't have to worry about any vertical or horizontal asymptotes. Now, the end behavior is actually really, really cool here. If we think about what happens as x goes all the way to the right, well, the end behaviors does not exist because it's actually oscillating. It's going up and down, up and down, up and down. It doesn't go up forever, it doesn't go down forever, and it doesn't cycle to a specific value. It just keeps alternating. So it literally just keeps going up and down, up and down. So when we talk about, hey, as x gets really, really big, what's the function doing? What's sine of x doing? What's y doing? Well, it's not going anywhere. It's bouncing up and down, up and down, up and down. We call that oscillating. So that's why there is no answer there. That does not exist. There's no specific number that it's approaching. Same thing towards negative infinity. And which is pretty cool. If you really want to understand this function well, we could actually type this into Desmos. So if we go to Desmos and type in sine of x. Now, we got to make sure we understand a couple things here. First off, if you just type it in, you're going to see the beautiful sine. And check this out. If you zoom out, you see that it really never ends. It just keeps going up and down, up and down, up and down. But a couple things is if you hit that wrench, first make sure you're in radian mode. Because again, as I mentioned, the input is an angle and officially it needs to be in radians. It can be degrees, but then we're going to 360, and it just, we don't like doing that as mathematicians. Sorry, pure mathematicians always use radians. Now, the other thing too is like, let's make the x-axis so that it makes sense, right? Like I can make the x-axis, remember it's in radians, right? Now, radians are numbers. They're not like this weird thing, that they are numbers, but it makes more sense if they're in terms of pi. So we could do something like -6 pi. Now, where do you get the pi? You got to get your keyboard here, and the pi is right down here. And then I could go all the way to +6 pi. And you don't have to do this, but just makes understanding a little bit better. And then my step is going to be that pi over 2. Pi divided by 2. All right, so now when I make my graph, check this out. I could zoom in, and I can actually see at pi over 2, it reaches that max at 1. At 3 pi over 2 reaches that min at -1. And then you see that cycle. We call that one period. One trip around the unit circle starts at 0, goes up to the max, down to the min, back to 0 at 2 pi. And then again, it does it again. From 2 pi to 4 pi is another wave. 4 pi to 6 pi, another wave. 6 pi to 8 pi, another wave. And we could also look backwards, going negative. If I go backwards to -2 pi, now again, I'm going backwards, so my first movement is down, so my y's get negative. I reach that min first. Then I go up to the max, back. So again, that's -2 pi. Another wave to -4 pi. Another wave to -6 pi. So I think looking at this in Desmos is actually really cool because you could zoom way out and see that this curve really does never, ever, ever change. And as you zoom out, it kind of gets smaller because you're zooming your y's. So another thing you could do is go to your wrench and you could change the y's to something like, just like -2 to +2. This way we really see those waves. Now again, it looks more compact, but that's just because I changed my y-axis. But you can see again, it goes up to 1, down to -1, back to 2 pi. Up to 1, down to -1, back to 2 pi. It's pretty cool. And you can even put your mouse on it and trace it. Now, again, when you start to trace it, you realize that they are giving you the radians as a decimal. So for example, it's 0.84 radians. The y-coordinate is 0.745. And then when you reach the max, it does give the nice exact value there, pi over 2, we are at 1. And we see that there's several maxes, right? Every time we hit that top of the unit circle, we hit that max again. And every time we hit the bottom of that unit circle, we hit that min again. It's pretty cool. You can see all that in Desmos. All right, now let's quickly turn our attention to cosine. Mostly a lot of things are similar with cosine, but there's a couple differences, but a lot of similarities, but a couple differences I'll point out. All right, so when working with the cosine function. So once again, we have that table here with inputs are radians, which again are numbers. They are real numbers. And the output, this is where you got to make sure you really focus. The output is the x-coordinate from the unit circle. So now we're tracking what happens to the x-coordinate as we rotate around a unit circle. So for example, when we plug in 0, cosine of 0 radians, at 0 radians, the x-coordinate starts out at 1. And I know a lot of kids get confused and say, well, why do you have y here? Why are you saying it's 1? The y-coordinate is 0. No. Listen, the y is just a universal letter that we use for the output. The output. The output to cosine is the x-coordinate from the unit circle. But in a function world, that's y. But I need to know that that y represents something. The y, the output, is represented by the x-coordinate from the unit circle. So at 0 radians, the x-coordinate from the unit circle is 1. And then at pi over 6, it goes to 0.866, or radical 3 over 2. At pi over 4, it goes to radical 2 over 2. So I could graph this as well. So once again, I'm going to use the second tick mark for my 1 and negative 1. So this actually starts at 0. So it starts at 0, 1. It starts up at 1. And if you think about the unit circle, as you start moving in a positive direction, your x's actually decrease right away. Yes, the point is going up, but up is the y-coordinate. So you're thinking about what's the x-coordinate doing, and the x-coordinate starts at 1, but the moment you start moving up that unit circle, your x's are actually getting smaller. So at pi over 6, it goes to 0.86. At pi over 4, we're at 0.707. At pi over 3, we're at a half. At pi over 2, we're at 0. And then, again, that makes that curve, right? And again, remember, you got to understand, the unit circle, right? The moment you start rotating, the moment your angles get bigger, the x-coordinate actually gets smaller. And then we keep going. So let's just jump to pi. We're down at negative 1. So again, they actually continue to get smaller and smaller and smaller and smaller until we hit pi. And then at 3 pi over 2, the x-coordinate is back to being 0. And at 2 pi, the coordinate is back to being 1. So we kind of make this curve. And now I'm drawing it. It should be nice, a lot more nicely curved than that. Now, to truly understand this, let's look at that unit circle, right? Again, this is where you really have to focus. As I start at 0 radians, what is my x-coordinate? 1. So that's why we start at 0, 1. Okay. And watch, don't think about the fact that I'm going up, because the going up is just the fact that my radians are increasing and my angle's getting bigger and bigger. But what I want you to think about is the x-coordinate of my mouse. And the x-coordinate is actually getting closer and closer and closer to 0. Again, track the x-coordinate. Track the x-coordinate. The x-coordinate is getting smaller. And when I reach pi over 2, the x-coordinate hits 0. So that is why, as I start to curve, I reach 0 when I hit that pi over 2. And then again, now I'm getting smaller and smaller. As I keep going, I'm getting negative now. Again, my x-coordinates are getting negative, and they're getting more negative and more negative and more negative until I reach the lowest, which is negative 1. So that's why I curve down here, and at pi, I'm at negative 1. And then again, I got to keep telling you, track the x-coordinates. So as I keep rotating, now the x-coordinates are actually getting bigger. They're still negative, but they are getting bigger. Again, I'm tracking the x-coordinate of my marker. Tracking the x-coordinates, getting bigger. And then at 3 pi over 2, it comes back up to 0. And then again, they keep getting bigger now. Now they're getting bigger. Now my x-coordinates are positive, and they're getting bigger. Every time I move, my x-coordinates getting bigger and bigger and bigger until it reaches at 2 pi, it's back to 1. But again, this pattern is going to continue. And even if I go in the negative direction, again, think if I start going down, my initial movement, if I go down, is that, again, my y or my x-coordinates are dropping. So my initial movement, my x-coordinates are dropping. When I reach negative 1/2, they get to 0. When I reach negative pi, they're down at negative 1. And then they come back up at negative 3 pi over 2, they're at 0. And at negative 2 pi, Again, negative 2 pi is just going all the way this way. So that's why, again, I end back at an x-coordinate of 1. Now, that's really crappy. I'm going to make this in Desmos, which is much more beautiful than my crappy drawing. But let's talk about behavior real quick here. So the domain is just like sine. The range is just like sine. I'm still trapped between negative 1 and 1, but instead of thinking of 1 for the x's and for the y's, it's about the x's, right? The x values. It's always continuous, no discontinuities. It's got a max at 1, a min at negative 1. And I know it's confusing. You're trying to say, well, wait a minute, the y value? I thought this is the x value. Again, you have to truly comprehend that all functions are graphed on an xy grid. X is input, y is output. Now, the question is that you have to understand here is, what does that output represent? And with the cosine function, that output represents the x-coordinate from that unit circle. So again, you have to truly get that this unit circle is nothing more than it's like an input-output table. It's just where I look to figure out my inputs and my outputs. It's really that easy. There's no asymptotes. The end behavior is just like sine. Oh boy, this is cosine. I can't believe I have that typo there. Cosine of x. Cosine of x. But again, because it's oscillating, it's not going anywhere. It's going up and down and up and down and up and down. So we don't really have an end behavior. The end behavior just does not exist. So once again, we could go over here. I'm actually going to graph this. I'm going to erase sine and type cosine of x. And again, look at that, right? And you can zoom out if you need to or zoom in. I don't care. But notice how it starts up here at 1. There it is at 0, 1. And then again, it starts to go down and down until it reaches its min, which is at pi radians, the x-coordinate, the output, the x-coordinate of the unit circle is negative 1. And then I come back up to 2 pi. And that's that full wave. So now the problem is if you kind of really zoom out, people are like, oh, is this sine or is this cosine? So here's an easy way to tell. Remember, sine starts at 0, 0. So you know you're working with sine if you start at 0, 0. And then your movement is up and then down, right? If you're cosine, you start up at 1. So it's all about understanding that you always start at 0 because you always begin at 0 radians. That's your input for the beginning, 0 radians. And then the output for sine is the y-coordinate, which starts at 0. The output for cosine to start at 0 radians is 1. So we kind of get that idea. So here is kind of two of these just rough pictures, right? These are nice pictures of what we call one full cycle or one full period. So again, here is sine of x and here is cosine of x. And again, the big difference to kind of do the eyeball test is if you start at 0, 0, you're going to be sine. If you start up at 0, 1, you're going to be cosine. Now, one period length is the length of one rotation around the unit circle or one full cycle of the wave. So one full cycle of the wave. Again, think about going around that unit circle. For sine, I start at 0. At pi over 2, I reach my max. At pi, I'm back at half circle. I'm back, and again, you can see it, half circle. And at pi, I'm back to 0. At 3 pi over 2, I reach my min at negative 1. And then at 2 pi, I'm back to 0. That's one period, one full wavelength. And then that period just repeats itself in both directions. But one full period is 2 pi. Same thing with cosine. One full period starting at 0 radians, which is an x-coordinate of 1. We then go down at pi over 2, we're at 0. At pi, we're at negative 1. At 3 pi over 2, we're at 0. And at 2 pi, we come back up to 1. So that's one full period. So the parent functions, sine and cosine, both have a full period length of 2 pi. It takes 2 pi to go all the way around a unit circle. Duh. Now, the amplitude is the distance the wave is from the midline, or half the height of the entire wave. So the amplitude is this height right here. This height right here, which is 1. So the amplitude is 1 for a parent function. Now, again, I actually say it's half the height of the entire wave because the entire wave goes from negative 1 to 1. That's a distance of 2. So half of that is your amplitude. So your amplitude is 1. The period, or I'm sorry, the midline, sorry about that. The midline is the line in the middle that we're waving around, right? That's the x-axis, or y equals 0. So here is my midline. It's the middle of the graph. And then again, I go up 1, down 1, up 1, down 1, up 1, down 1. So you make that wave around the midline. So same thing with cosine, right? Cosine has the same amplitude. The amplitude is the height of the hill or the depth of the valley. You can look at it like that, but amplitude is a distance, so it's always positive. So again, it's this distance from the midline to the top or the midline to the bottom. That's a distance of 1. Or again, like I said, you could think of the entire wave has a height of 2, -1 to 1. Therefore, the amplitude is half of that, or 1. And then again, the midline is the middle that you're waving around, right? So this constant motion of starting up, going down, back up, down, back up, down. So that's where we get these ideas of midline, amplitude, and period. So those are some big definitions you need to know. And what we're going to work on moving on to the future is actually finding those values when we see a function. Finding the period, find the amplitude, find the midline. We'll keep working on that as we go. All right, so the last thing I want to talk about here is the big 5 points, the big 5 points. So as we follow the basic one period, let's just focus on one period, there are 5 key points. And this is the axes of the unit circle. So when we think about that unit circle, we're starting here on the far right, then we go to the top, then we go to the far left, then we go to the bottom, and then we go back full circle to where we began. So those are the 5 points. 1, 2, 3, 4, 5, back to where we began. So for sine, those 5 key points are 0, 0, and then we reach our max at pi over 2, 1, and then we reach the midline again, right? We're back to the midline at pi 0, and then at 3 pi over 2, we're down to our min at -1, and at 2 pi, we're back to 0. So those are called the 5 points. So as long as you can find those 5 points, then you just make that nice curve in between them. Same thing for cosine. We've got these 5 key points for cosine. We start at 0, 1. That was the beginning. So at 0 radians, we start at that x-coordinate of 1. Then we come down to pi over 2. Our x-coordinate is 0. At pi, the x-coordinate from the unit circle is down to its absolute lowest at -1. At 3 pi over 2, we're back to 0. That's that midline. And then at 2 pi, we're back to where we began at 1. So that's that one full period. And if you understand these key 5 points for both functions, and they're very similar, right? It's all about where you start. Sine starts at 0, 0, cosine starts at 0, 1. Those are the 5 key points that we're going to focus on for a lot of the graphing that we're going to do in the next video. And those 5 points, if you have those 5 points, it's so easy to connect the dots with a nice smooth curve. That way you can really make one full period. So what we're going to talk about in the next video is to actually start making transformations. Right? We've learned that in the past. We could slide it up, slide it down, left, right, stretch it, shrink it, all that fun stuff we'll talk about in part 3 of graphs of sine and cosine. But these 5 points are really important. These are, again, on the unit circle. These are the nice whole numbers, the axes. And this is where we reach our max. We come back down. We hit that midline. And we hit our min. So hopefully you understand this. If you need to pause and process. But you should know what one beautiful period of sine looks like and what one beautiful period of cosine looks like and the 5 points that create that. All right, guys, stay tuned for part 3.